In this lecture, we'll talk about routing and rules. Routing refers to the copper tracks that will be on your circuit board. It'll be on the top layer and the bottom layer and the standard two-layer board. In our board, we're just going to use two layers. And then rules. The rules are going to define a lot of our properties. They'll define how wide the trace is, how close can two traces get. There's a lot of functions. So let's look up here, up in our toolbar. I have design, and under design we have rules. I'm going to click on rules, and here's a list of all the possible design rules we're going to deal with. We have electrical rules, routing rules, surface mount technology rules, mask rules, plane rules, test point, manufacturing, high speed. It goes on and on. Let's look at the routing rules. Routing rules are going to tell us how wide our traces are going to be. So here's our default. Here's the constraints. For everything in here, preferred width 10 mils. That's 10 thousandths of an inch. Maximum 10 thousandths, minimum 10 thousandths. Attributes. This is going to be on the top and the bottom layer both, right? So it gives us some possibilities. Here's one that says routing layers. What layer are you allowed to route copper on? Currently it's set at top layer and bottom layer. So we'll leave those where they are. First thing I'm going to do is let this thing route by itself. I'm going to go to the top where it says auto route. I'm going to click all. I'm going to leave it on default two-layer board. Now this is a routing strategy. This is kind of the algorithm they use to try to calculate where we can place traces and how we're going to get the copper to move there. I'm going to leave it just like it is, and I'm going to tell it route all. I just want you to route it for me no matter how messy you are, just so I can see the traces. So I tell it route all. I watch my messages here. That's important because it's going to tell me routing finished with 0 contentions. A contention is trying to get one trace to go over the top of another. Obviously on the same layer you can't do that. It would create a problem, a short circuit. Failed to complete 0 connections, and it did it in 2 seconds. So now I know my board routed correctly. Let's just take a look at it. Now remember our colors. My red is copper on the top. My blue, copper on the bottom. So I can see my different color coppers on the top and bottom for my different layers. I can zoom in, move around. You'll see that these two traces are right next to each other, but that's on the bottom. This is on the top. Not a problem. No shorts. Let's see how we look. It looks like it did an okay job routing. A little bit crazy jumping around here, but that's what we had to do to get our traces where we needed them to go. That's one way to route. Maybe not always the best way to route, but that's one way. Let me go to Tools, and under Tools I have Unroute All. Boom, I can unroute them. There's another way to route. There's an interactive routing. So if I come back to my toolbars up here, you'll see when I hover my mouse, interactively route connection. If I click on that, I can route this connection. So if I come here, you'll see it highlight when I get on that net. I click, and because I was on the bottom layer tab when I clicked, I'm now going to route with bottom layer copper. I can come right over here and click again until I've routed that connection. Now if I click top layer on my tab down here, come back to my interactive routing, I can click this net and we get red. Why do we get red? Because I'm routing. See it go around. It's going around. Let's zoom in. It's easier to see. I'm telling it to go straight across. It's going where I tell it as much as it can. And then if I tell it go there and then go down, you'll see where it moves in between those pads trying to route. Right? It can't touch that spot. That's a different net. All the time trying to get here. So that's one way. Another way to route interactively. one net connection at a time. You can route it yourself. You can kind of move these after you've routed them if you want to. It'll make for crazy circuit boards doing this, but that's a possibility. Looks pretty ugly. Let's get rid of those. I'm going to zoom all. I'm going to come back to my auto route all. I'm going to tell it to route all, just for fun. And here's my circuit board again, routed. Everything's routed. And what do I see here? Well, I see all my connections are routed. It looks fine, not really a big deal. But I kind of see my ground trace is not very big. And maybe I want my ground trace to be big, right? But my other trace is not to be big. How do I do that? Well, let's take a look. I'm going to go back to my schematic. And inside my schematic, I'm going to place a rule. You'll see under Place, up here in the top, I can come down to Directives. I'm going to direct it to do something. PCB Layout. I'm going to direct a PCB Layout Rule. So right here on my ground net, or even before I place it, I'm going to use my same old trick. I'm going to hit Tab before I place it. I'm going to tell it Add a Rule. I'm going to tell it Edit the Rule. Edit Rule Value. I'm going to come to Width Constraint. Right, this is my routing, width constraint. And I'm going to tell it maximum I want it to be is 30. Minimum I'll put at 20. But I would really like my traces to be 25. That's my preferred width. So I save those. I place my rule right here on the ground. So I can save that now. And now I need to update my schematic information to my PCB. So let's go to Design, Update PCB. It wants to add the rule, execute changes. I've added my rule, and what happened? Look at my traces here. Everywhere I had a ground trace, it's now green. Right? See that green color? Green is the color Altium uses to tell you there's an error, there's a problem. So let's find out what's the problem. I'm going to go to my trace here, right click on it, and I'm going to say Violations. What's the problem? And it says width constraint, violating primitive, bottom layer, actual width 10 mils. Needs to be bigger, right? So let's do this. Let's show all, tools, under tools, unroute all, auto route all, route all, and let's see what happens. Now look, my ground trace is now how big? Let's double click on it to get the properties. 25 mils. So now I can have my rules set, and inside my rules, let's look inside the rules now. Under my width, I have two rules now. Here's my schematic width constraint on this net, right? And there's the width for everything else. So now I have two rules in there. I've changed my rules, I changed the width. And I was able to route my board here with a fatter trace on my ground. Now here's a quick side note before we finish this video. This piece of copper is red right here on this B and C connector, and that is on the top layer. When I put this component on this board to solder it, these connections will be soldered from the bottom because they come out of the bottom of a little black cube of plastic. So I can't see this connection on the top. Here's the problem we run into on boards milled here on campus. Let's go back to our design. Layer Stack Manager. When we build boards here on campus, we use a laser machine. The laser will cut and remove all this extra copper and leave just our traces. And then the machine drills these holes. We don't have a way to plate these holes through. So this connection from the top to the bottom is not plated through. You have to solder the top and the bottom both to get that connection to go through. Here's the problem we run into. I have no way to get under here to solder this. I can only solder it from the bottom. What am I going to do? Well, I have some options. I can double click this trace, tell it be a bottom layer, just change its layer. No problem. That's all on the bottom now. And that will work here too. I can double click this, tell it bottom layer. Okay, good. No errors. That's on the bottom. I can reach everything else. I'm good to go. Remember this capacitor C6? We put it on the back of the board. We can look here and what happened? The traces are on the bottom layer. Now, what would happen if I unrouted everything? I went to my rules, and under layers, I told it, don't route the bottom layer. Just route the top layer. I don't want any copper on the bottom. I tell it auto route all. Route. The router runs, calculates, does its job. Finished routing with zero contention. Wait a minute. Failed to complete 2 connections. Didn't make 2 connections. Why not? Why couldn't it finish them? Look right here. Remember the surface mount part I put on the bottom? I placed a surface mount part on the bottom, and then in the rules I told it you're not allowed to put any copper there. I basically set Altium up to fail. So if you have problems like this, and this is kind of obviously a crazy problem, but if you have a problem like this, it's because there's a rule somewhere set that it can't do it. And in this case, I made a crazy rule and I told it route this thing on the bottom. So let me double click my part. So I changed my mind. I want you back on the top layer. And I'll put you right there's good because I'm going to reroute everything. I'll do Tools, Unroute All, zoom so I can see it, Auto Route All, Route All. Routing finished with zero contention, failed to complete 0 connections. I got everything routed, and how did it route? Look, no blue layers. There's no blue. There's no copper on the bottom because I set a rule that said you can't put copper on the bottom. Let's go back. Design rules. I'm going to allow it to have copper on the bottom again. We'll do Tools, Unroute All, and save our project. Okay, at this point I think we're good for this video. On our next video we're going to talk about internal layers, how to make a board with more than 2 layers. We can have signals on the inside and we can have power planes on the inside.